Hey guys, welcome back. Today marks our last day of content for Unit 9, Surface Area and Volume. So today's Wednesday, and then tomorrow and the next day, so Thursday and Friday, you guys will have one task for both days, which is to work on your take-home test. The take-home test is going to be just like a Google form, so it should be pretty straightforward. My goal is to make it just like if you know the basics, you should be able to easily get a good grade on it. So I'm going to be releasing the original take-home test, and then I'll have a second quiz, which will be the retake, and you can retake it as many times as you need until you get to a place where you're happy with your score. So that will be the next couple days. Today we're going to be looking at spheres and composite shapes, where there's a couple shapes put together. Our math meme today is that we have a triangle and a circle talking. The triangle says you're pointless, and the circle says that's how I roll. Kind of seemed appropriate looking at spheres today to look at circles a little bit. So to start us off, we've got our warm-up. And then we're going to do spheres and some practice problems. We probably won't go through all the problems here. I'm just going to pick out the important ones that I think would be critical to go over. So anything we don't go over you can do for practice if you like, but you don't need to. So to start, let's just do a quick warm-up to see how we're feeling with our volume of a cone, right, which was our previous topic. So we've seen volume of prisms and cylinders, right? The first one was prisms and cylinders, which are things like this, as well as things like maybe this, right? So we've seen that. We've also seen cones, and we saw pyramids as well. Okay, remember the first two, your volume was area of the base times how tall, the height. The last two, the volume was going to be 1/3 times area of base times height. You could write it as 1/3, or you could write it as area base times height divided by 3. Okay, so pause the video, go ahead and use your formula to figure out what the volume of our cone is with these given measurements. Okay, so here is my worked out solution for the volume of a cone. Notice it's 1/3 times area of base times height. The area of the base in this case, I did that work in pink. It's a circle, so you have to do pi r squared. To get my final answer, I left it in terms of pi. So what I did on my calculator, I kind of highlighted it here for you guys, is I looked at just the numbers, and they were all being multiplied, so I can multiply whatever order I want. And so I did 121 times 13. And then instead of doing times 1/3, I can also treat that as cutting it into 3, so dividing by 3. And I got 605, and I tacked back on my pi, and my units are cubic centimeters. Now, you guys should, if we look quickly at our formula sheet, you should have your sphere volume right here. What we're going to do is we're going to look at why that is the formula for the volume. So I've got a little video for you guys, and I think the video is actually really helpful, and I think it's a really good video to get through the concept. So I'm going to play this video for us, and we're going to use this as part of our lesson, because this is normally what I would do on the screen.
So we're going to discover where the formula for the volume of a sphere comes from. In a previous video, we saw that it took 2 cones to fill a sphere with the same radius. So we'll now go back to recall the volume of a cylinder. And if we remember, the area of the base is pi r squared, since the area of a circle is pi r squared, and we can get the volume of that cylinder by multiplying by the height. We later learned that to get the volume of a cone, we would take the volume of the cylinder with the same height and same radius and simply divide it by 3. As we saw in the experiment, it took 2 cones to fill up a sphere with the same radius. It's important to note that that would mean the height of the 2 cones would be the same as the height of the sphere. And the radius of the two cones would be also the same as the radius from the sphere. So what this really means is that we could find the volume of one of these cones and simply add another volume of a second cone to determine the volume of a sphere. But this isn't necessarily the most efficient way. If we analyze the relationship between the radius of the cones and the height of the sphere, we'll see that 2 radii is equal to 1 height of the cone and 1 height of the sphere. So rather than calling the height of the cone h, we could essentially replace h with r plus r, or 2 times r. Following mathematical convention, we'll bring the coefficient of 2 to the front of the term. And simplifying r squared times r, we get r cubed. Simplifying further, we'll notice that we have 2 fractions, 2/3 pi r cubed, plus another 2/3 pi r cubed. So let's write this a little differently to make it look a little easier to work with. While we can likely see that 2/3 plus 2/3 is 4/3, let's put them together to make this a little more obvious. Since we have a common denominator of 3, we could put our 2 plus 2 in the same numerator over 1 denominator of 3 to get 4/3 pi r cubed, which can also be written as 4 pi r cubed over 3.
Okay, so let's get out of this. Okay, so we're going to write our formula on our spot over here. Notice it's also on your formula sheet in the section for volume. Remember, volume is your second row. So volume 4/3 pi r cubed. And we are going to go back to our notes. And our volume is 4/3 pi r cubed. Okay. So we're going to use that. You will never have to explain why that is the formula. I just really am a big supporter of helping you guys see why formulas work and explaining where they come from. That way you guys don't feel like I'm just giving you random things to memorize, that sort of thing. Okay, so let's look at the first example. We're going to look at a couple of straightforward examples just to make sure you guys understand what's going on. So the volume of a sphere is 4/3 pi r cubed. Remember, we need the radius. This is your diameter. So radius is halfway across, whereas diameter is all the way. So I'm going to do 24 cut in 2 and get my radius as 12. So my volume is going to be 4/3 times pi times radius of 12 cubed. Okay, so on my calculator, I want to do 12 cubed, which I can do 12 caret 3, or you could do 12 times 12 times 12 if you don't have the caret. So it's 1728. I want to do the 1728 times 4/3. So I can do that in 2 different ways. I can do times in parentheses 4/3, like that. Or you could also do 4 divided by 3 times 1728. Now notice doing that, you want to do it immediately after, so it pulls the last answer and gives you the full rounded answer rather than rounding it prematurely. So let me write that out. I had the 4/3 times pi times 1728, and then we took these two guys and we put them together and we got 2304 pi inches cubed. Now notice, because I used second answer, I got the exact answer. If I had done something like 1.33 times 1728, notice it would have been off by a little bit and it wouldn't quite be the exact answer. So I just wanted to point that out, that we wouldn't be equal. Okay, so that's one example. Let's look at example 2, the volume of a hemisphere. So I know that the volume of a sphere is 4/3 pi r cubed. So I'm going to take the volume, and then at the end, all I'm going to have to do is divide it in 2. Okay? Because it's half of the sphere. Notice this one for the volume, it's actually a little bit easier than surface area. Surface area, you would have to take half of the surface area, right, to get just the outside bit, but you would also have to take into account the area of the circle. So it's a little bit easier because there's only really one step for volume. It's just cut it in half. So the volume of my sphere is 4/3 times pi times the radius of 15 cubed. So here on the side, I'm going to pull up my calculator. I'm going to do 15 cubed. And then I'm going to do that times, in parentheses, 4/3. Remember, your other option is to do 4 divided by 3 times, what was 15 cubed? It was 3375. And you'll get the same thing, 4,500. So it's going to be 4,500 pi meters cubed. And then I want to divide by 2 because I want just the hemisphere, right? So it would be 2250. Still have the pi, and it's still meters cubed because we're measuring our volume. Okay, so I would say that these two first examples are definitely your core examples. These are straightforward, just bare bones. Can you plug it into the formula and get your final answer? We're going to look at maybe 1 or 2 working backwards. I don't know how much we'll get to composite. I was going to show you an example of composite, just practicing a couple of shapes put together is all. And that's all that composite was. It was just supposed to be extra practice if we had time. So working backwards, let's rewrite our volume formula, 4/3 pi r cubed, just to have it there for us. Some working backwards problems, I would call these more your standard. Okay, and we're going to be starting from a volume and trying to go backwards and figure out what some original measurements are. So I'm looking for the radius, but I know what the volume is. So 4/3 pi times radius cubed equals 288 pi. So I generally do this, and I plug in everything I know into the regular volume formula, and then we have to think about how to go from the 288 to get our radius. So let's see, that's just plain numbers. So that's going to represent this part, which is plain number, and normally we have a radius, which is just a plain number. And the pi is kind of matched here, so we can kind of ignore the pi. So I know that 4/3 times the radius cubed is equal to 288. So we want to think about this kind of like undoing, right? We're solving. If I'm solving for radius, I have to undo times 4/3. So I'm going to do 288 divided by 4/3. Oops. 288 divided by, in parentheses, I'm going to do 4/3. Looks like it's 216. So radius cubed is 216. And now here's a interesting part here. If I want to undo cubing, it's something called a cube root, which on your calculator, if you have this kind, you can go to Math and scroll down to the cube root option and do the cube root of 216. Some calculators might already have a cube root button, others might not. If you don't know how to get a cube root on your calculator, you could also just Google it and look it up online for a cube root, right? Or use a calculator on your computer. Okay, so our radius is 6, and I don't think they gave us units. And then we have one more, the regular square pyramid, and this is a good practice one just to practice how we feel about pyramids. Okay, the height is 15, so from the very top straight down, that's your height of your pyramid. And the volume is 1815. What's the length of the base? So I'm going to pause this, and I'm going to set it up. I want you to unpause once you want to check your work. Okay, so I set it up, putting everything into the formula I knew. I then did a third times 15 on my calculator, and I got a 5. And I simplified that a little bit. And then I did some solving, and I got about 19 meters for the side lengths. Notice it's a square pyramid. That's how I knew to get my sides as x and x. The other problems in here are just extra practice if you would like. You are not required to do anything past here though.